So in this case, I want us to consider this typical test, which was for September. So this is from the Summaries SA. If you want to buy your question papers, so they actually sell question papers. You can check for yours there so that you can make your revisions to be easier. If you just use this, I think you can get to these question papers, guys. There are a lot of question papers there that you can actually consider. So this is for September that we are going to consider and see in our revision. So the major part is not for us to work these questions that we are seeing here, but it is for us to understand what is it that you're supposed to be working with in this term. Remember, I talked about this, that you're supposed to understand your algebraic expressions. You're supposed to understand your algebraic expressions. You also supposed to understand your algebraic equations before you enter the exam room or before you write your test. This is what you need to understand: the algebraic equations, and also you need to understand the geometry. Remember, we talked of the geometry of straight lines. This is what you need to understand: the geometry of straight lines. Then also the geometry. Okay, the other part of our geometry is the geometry of 2D shapes, the two-dimensional shapes. Okay, so this is all that you are supposed to be expecting in your test. So sometimes it depends with the school that you are from. They can bring some of the activities that you had before from your previous, like from your term one, term two, but we are supposed to be having this in term three. Okay. Like I think I showed you guys the ATP, annual teaching plan, that you're supposed to be assessed all term three topics, all term three topics, which means all of these. So please do yourself a favor to make a revision. All right, so let us quickly rush through our questions and see. Number one, we are given: choose and circle the correct answer. All right, 1.1. So you're supposed to choose answer from these answers that we are given. All right, so on 1.1, you're given an example of a binomial is, okay, so let's start here. Binomial, what is it that we are referring to? Remember, this is a polynomial consisting of two terms. So it consists of two terms. Remember this, a binomial supposed to be having two terms. So of these polynomials that we have, which part that we are having a binomial where there are two terms? So if we check the first one, that's 1, 2. There are two terms there. So this is the one that we are referring to as a binomial. B, there's only one term. It's only a single term. This one, 3xy, it's a term, this one. It's a single term. So what is it that you're considering there? That is a monomial. Okay, that is a monomial, like that. So that is what we have, mono. Okay, guys, sorry for that. We have got mono there for what? For one. Mono for one. How many terms? Let's see. 1, 2, 3. What is it that you're talking about there? That's a trinomial. Okay. That's a trinomial here. D, how many terms? 1, 2, 3, 4 terms that we have. But in this case, because we've got 4 terms, that is a quad. So this one is going to be quadrinomial. So the most important part is the quad. 4, tri, 3, mono, 1, bi, that is 2. So in this case, our answer was supposed to be the A, this one, where we have 2. Okay, let's move on to 1.2. Choose the correct answer. They are asking you for the correct answer. meaning to say the correct statement of these statements that are given below, which one is correct? Okay, let's start. A coefficient means to divide. Where is this taken from? No, this does not exist, guys. That's not a coefficient. We understand if I am given 2x, if I am given 3y, if I am given 3x squared, whatever that I'm given, any term, like whatever term that I'm given, the coefficient is supposed to be the number that we are seeing in front of the variable. The number here, this one, in front, this one. There we've got the variables. So that is not to divide. A coefficient is the highest power in an expression. No, this is not. A coefficient is the number in front of the variable. That is exactly what we are seeing here. That is a coefficient. The coefficient of x is 2. The coefficient of y is 3. The coefficient of x squared is 3. So these are the numbers in front of the variables. So that is going to be C. D, an example of a coefficient is x. This is totally wrong because a coefficient is a number, not a variable. X, it's a variable. X, it's a variable. X. The coefficient of x is 1. So x is not a coefficient. It is a variable, a term. All right, so that is what you're supposed to have. So the answer is going to be C. That is the true statement that we have there. On 1.3, we are given the third angle of a triangle with angles 28 and 104 would be the third angle of a triangle. A triangle, what is it that you think about? A triangle. The angles inside, the interior angles of a triangle, they add up to 180 degrees. Remember from the properties of a triangle. So if they add up to 180 degrees and we are given two angles, we are given two, how can we find the third one? Like we are given this angle, we are also given this angle, and you want to find this one that is remaining here. How can you find it? You are going to simply subtract these two angles from 180 degrees. We are given two angles. We need to find the third one here. So out of 180 degrees, we are going to subtract the two given angles. So that's, you subtract 28. We also subtract the 104 degrees. So that was going to give us the remaining angle, which is the third angle of the triangle. And that was going to be 48 degrees if you subtract properly. So that is on D. So on how to subtract, you can even do it like this. Some, they can subtract it this way. 180 degrees minus, you add these two. Once you open a bracket, you add these two angles that you want to remove from 180 degrees. So that is the concept. You can even simplify it that way. Or you can simply subtract each angle from 180. So it's 180 minus this, minus this. It's still one and the same thing. You're still going to have the same answer. So it's different way of presenting. I don't know which way that you understand. Let us work with exactly the way that we understand. On 1.4, 2 times a number added to 8 equals 12 means, okay, 2 times a number. We do not know. Once you're given a number, 2 times this, 2 times a number, you do not know that number, okay? You do not know the number. So let that number be x. You check how they are given there. Are they given in terms of y, in terms of x, in terms of m? So these ones are given in terms of x. So let that number be x. So they are saying 2 times here, 2 times, 2 times is to multiply. So that is 2 times a number. So 2 times a number gives us what? 2x. Okay? Added to 8. So this number that they're saying 2x, the 2 times a number, is added now to 8. So to add is to simply take this 2x, we add 8 on it. 2x plus 8 is equal to, take note, guys. They have an equal there. They are saying is equal to. So there must be an equal sign. It is equal to what? To 12. So this is what they're saying. 2 times a number. If you multiply a number by 2, then you add 8 to that, you must get a 12. So which one is properly presented here? Okay, number 1A, this is totally wrong. Okay, this is wrong. Okay, on C, this is what we want. So our answer was gonna be C. Okay, D is totally wrong. 2 times a number, it's 2 times x, and 2 times x means 2x. Wherever you get an x squared, it means you are multiplying x and x. That is where you get x squared. But 2 times x, it gives you 2x. So this one was a tempting part, this one, for someone who is having challenges with multiplication of this. You multiply 2 times x, then you write it as x squared. You're going to be tempted now to use B as your answer. That is wrong. Okay, so our answer was going to be on C. 1.5. Supplementary angles add up to, okay, as long as you're talking of supplementary angles, they add up to 180 degrees. Are they on a straight line? Wherever the supplementary angles are located, these are two angles that when you add them, they're supposed to give you 180 degrees. So the answer was supposed to be A there. Okay, so that is what we had on the first part, number 1. Let's check number 2. So on number 2, we are given provide detailed names or structure for the following shapes and angles. E.g., we are given, this is an example, this one. So they gave us a triangle, and they're saying it's a right angle triangle. Okay, you can see that this is vertical, which is, that is the way that you're going to answer also. Like, this is an example, like what you have, like what you can be given to say. They can give you is to say it's a right angle, then you draw it, or they can draw like this, then you answer to say it's a right angle triangle. So that is what they want you to be doing in these questions. So let's check on this one. They gave us on 2.1, let's start with 2.1, perpendicular, because there's nothing here, so they want you to answer here. What is it that you're supposed to answer here? Perpendicular lines. So you're supposed to indicate how perpendicular lines are presented. So perpendicular lines, we are talking of what? 2 lines that are meeting at that meet at 90 degrees. These are 2 lines that meet at 90 degrees. So you indicate with a vertical line and a horizontal line like this. This is the indication that we see whenever we are presenting what? Perpendicular lines. If you want to write that AB is perpendicular, like this, is perpendicular. AB is perpendicular to CD. Like, you want to write, you look, this whole part that we are seeing here, guys, here, this whole part to say is perpendicular to can be replaced with this sign, you can simply write as AB is perpendicular to CD. So this indication is for perpendicular lines. Parallel lines, you indicate like this, parallel lines. So that is what they wanted you to simply indicate, like how do we see that lines are perpendicular? You can even just indicate two lines like this, then you put a 90 degrees. It's still one and the same. Still one and the same thing. You are still showing that the lines are perpendicular. Okay, let's move on to 2.2. On 2.2, they gave us a shape. They want us to write like what here? They gave you this and they're saying it's a right angle triangle. So this time they gave you this shape. What is it that we can say about this shape? What type of, the moment you see this type of a shape, this one, you are supposed to know the name of the shape. You're not supposed to be told. You're supposed to just by looking at it. Guys, this is a parallelogram. We can even see these two sides being parallel. These two sides here being parallel with opposite sides. With the slanted, this slanted part that it is, that's a parallelogram. The shape on its own, you're supposed to know it. So they can give you any shape. So meaning to say you are supposed to revise the properties. I think I listed on the quadrilaterals, each and every part. So make sure you go through that, know the properties. A parallelogram, you talk of a trapezium, you talk of a triangles, you talk of, is it an isosceles triangle? Is it an equilateral triangle? Anything about geometry, they can ask you that. So go through all those revisions. You see, it's all about geometry, all this right angle triangle. So let's revise as much as we can for our preparations. Alternate angles. If two lines are parallel, that is where alternate angles are produced. We know these are taken from parallel lines. You'll be given two lines that are parallel like this. And alternate angles are the ones that will create a Z, like on this. They create a Z, like they create a Z. So you can indicate alternate angles, this angle and this angle. They create a Z, alternate angles. You can also talk of this one. That's alternate angles. This angle here and this angle here. These are alternate angles. So you can just indicate like that. That alternate angles, they create a Z. So you're back to the properties of parallel lines. 2.4, what is it that we are seeing here? This presentation of this angle. It's an angle which is true, but what type of an angle that is open like this? Because angles can be like this. Can just give an angle like this. You see, I know this is an acute angle, this one. They can give us an angle that is like this. No, that we are talking of the obtuse angle. What about this one? I mean, we're talking of the, if it is like this, we're talking of the reflex angle. It is like the whole of this other part. It will be a reflex. But what about this one that we are given there? That's an obtuse. By just looking here, you can see now, it's an obtuse. An acute angle, we are below, like this is how we can take it, guys. This is a straight line, remember. So an acute angle is just below 90 degrees. So it can be something like this. We can see, all right, I know this angle that is given here, it's an acute angle. If the angle is somewhere here, we can say, I know this is a right angle. After this 90 degrees, after the 90 degrees, when the angle is now like this, open like this, look, guys, the 90 degrees was here. This is where the 90 degrees is here. And we are now having another angle also, part of the 90 added to the 90 degrees. So it's now an obtuse angle. So if you check properly there, okay? Here, I was going to have a straight line, 90 degrees, then another angle is there. That's an obtuse angle. So you're not supposed to do all these to check to say, no, guys, by just looking into the angles, you're supposed to know, okay, this is an obtuse, or it's an acute angle, or it's a reflex angle. Okay, so this we said an obtuse angle. That's an obtuse angle. That's what we can say. 2.5, they are giving us equilateral triangle. So what is it that they want? They want us to give a structure of an equilateral triangle. You see now, I was talking about these triangles before. So an equilateral triangle, we understand that it has all the sides which are equal. All the sides, all, like this side is equal to this side, is equal to this side. That's how you can indicate it. You can indicate in terms of the angles, because we know that the equilateral triangle, each and every angle inside will be 60 degrees. You can indicate in terms of that. They will know that this is an equilateral triangle. I don't know which way that you can put. You can indicate in terms of angles. You can indicate in terms of the sides, any one that you want, like this. Just to indicate like this, it shows that all the sides are equal. An isosceles triangle, if it was an isosceles triangle, two sides are equal, like this. Or you can be representing in terms of the angles, the best angles opposite to the given sides. That's an isosceles. A scalene, nothing that is not equal to this side. All the three sides are not the same. That's a scalene. Okay, so we have got a scalene triangle and a isosceles triangle. That's it. So let's do revise as much as we can. All right. Then move on to question 3, which had 19 marks. Question 3. 3.1. Do the following calculations without the use of a calculator. Without the use of a calculator, okay? Show all your calculations. 3.11. Subtract, take note, subtract this whole part from, that is the most important, from here, from, you take this one, that is where we are subtracting this from this, from, that is where you've considered. So it is supposed to be 7x squared plus 3x minus a 4. We remove this from this. So that is what, so it's gonna be minus, what are we subtracting? This whole part. So you can open a bracket like this, then write it as 2x squared plus 3x. I'm gonna show you another way, do not worry, plus 3x minus 5. That is what it means. You are subtracting the whole of this from this one. So you must indicate with a bracket to show that everything is going to be affected by this subtraction. So now we can distribute throughout. That is going to be 7x squared plus 3x minus 4. This part just rewrite as it is. Let us distribute this bracket because the minus means there's a minus 1. So we can distribute by negative 1. It multiplies each and every term inside. Minus 1 times 2x squared minus and a plus, that's minus. So that will be minus 2x squared. Minus 1, it multiplied here. It also multiplies here every term. So it's minus 1 and the 3x, which is going to be minus 3x, minus and a plus. You move on, minus 1 and a minus 5 at the end. So it's minus, minus, that's a plus. You're multiplying a negative to a negative. It will give you a plus. At this point, where you have distributed each and every term by this negative outside, you are now going to consider the like terms. Remember the concept of the like terms. Where we have this part of x squared, this is the part of x squared, this 7x squared, must correspond to also where there is an x squared. this one. Minus 2x squared, the whole of it. Where there is x here, we've got 3x, this part here, the 3x here that we are seeing, must correspond to the 3x again, there, the minus 3x, x and x. The constants, which are the numbers on their own, the minus 4 and the 5, these are constants. You consider this separately. So meaning to say, guys, we're going to have 7 minus 2, the 7x squared. So it's 7 minus 2, which is going to be 5x squared. You move on to the part of x, this one, the 3x and the minus 3x. So it's 3 minus 3, guys. 3 minus 3, that's a 0. So it will be 0x, meaning to say there's nothing there. It's just going to be 0x. There's nothing. Then we move on to the constant, minus 4 plus 5. Minus 4 plus 5 simply means 5 minus 4, which is a 1. That's it. So we're going to remain with 5x squared plus 1. Or we could have just taken it this way. Okay, could have just taken it this way instead. They're saying subtract this from. So you're just going to write, remember, from. This is the most important part. Where are we starting from? So we can just even simplify it this way. 7x squared plus 3x minus 4 like this. What are we doing? We are going to subtract. So it's going to be minus. What are we subtracting? This. So we write it as 2x squared below, following the part of x squared, the 3x. So it's going to be plus 3x. Okay, minus 5. Following, they're supposed to be x squared, the x and x following like that. So guys, you can subtract it like that, direct. So meaning to say it is going to be, the subtraction part is affecting, like here it's 7 minus 2. Okay, so if you understand that way, you can even do it that way. 7 minus 2, that is 5. So we've got 5x squared. 3 minus 3. So 3 minus 3, that's a 0. So that's a 0. There's nothing there. So you're just going to write, maybe it's plus, but there's nothing. There's nothing here. Okay, you move on. Minus 4 minus 5. So it's minus 4 minus 5, like this. That is what it means. So there is a minus and there's a minus. So it gives us a plus. So it's minus 4 plus 5. And that was going to give us a 1. So that's plus 1. So as you can see, we're going to have the same answers. I don't know the way that is easier for you, just to present them like this direct. Like just like you're subtracting 7 minus 2, you can just put it this way. So you can even write your expressions that way. Okay, so let's revise as much as we can. So as you can see, I've got the same answers there. Let's check another part of question 3, which is 3.12. Simplify. 2x plus 4 over 2. What is it that you're supposed to do? So that is a fraction. And we've got a single term, one number in the denominator. So I said this you can easily separate. 2x plus 4, you can easily 2x over what? You're separating by 2. You move on to 4 over 2. So that's a plus 4 over 2 every term. So what are we going to have? This can divide 2 and 2 guys can cancel, because they are the same. So they can cancel. You remain with x. So that was going to give us x. 4 divided by 2. That's a 2. 2 into 4. It is going to enter there 2 times. So you're going to remain with x plus 2. So given a single term in the denominator, you can simply divide, separate 2x plus 4 over 2. This is supposed to be affecting 2. 4 also is supposed to be affected by the same 2. Separated like that. So that is the idea there. 3.13. We have to simplify. What is it that you're supposed to simplify here? If you consider there are brackets, so definitely you have to expand. 4 into x minus 3 plus 2 into x plus 4. So you distribute by 4 times x, that is going to be 4x. 4 times minus 3, that is going to give us minus 12. You're done with this first part. You move on to the second bracket. Remember there are two brackets. We affected this one. Now you move on to the second bracket. What is affecting the second bracket is the plus 2, this one, plus 2. So it's a positive that we have. So 2 times x, that is going to be 2x. 2 times 4, that's a plus and a plus. That is going to be plus 8. You're multiplying there. Now you can consider your like terms after this. X together and x here. These are the like terms. Remember? The constants, the minus 12 and the 8. These are the like terms. So what are you going to have at the end? Okay, so let's add the x. 4x plus 2x, that is going to be 6x. Minus 12 plus 8 simply means 8 minus 12. Let's start with the positive, which is going to be a negative. That's minus 4. But under an exam condition, then you can simply use a calculator, guys. No one is going to even understand that you've used your calculator or not. You are in an exam and there is no time there. You can just, okay, use my calculator here. 3.14. If a rectangle has a width of x and a length 3x, 3.141, write down the calculation for the perimeter of the rectangle. You have a rectangle, guys. And this rectangle, it's like this. Remember a rectangle? First, we've got the width, which is x, the shorter side. This is the width. And the opposite sides of a rectangle, we do understand they are equal. The length is 3x. So this is 3x, and this is also 3x. And they are saying, write down the calculation for the perimeter of the rectangle. How do you calculate the perimeter? Remember, perimeter is the distance right around the shape. So we are going to add as we move around the shape, the distance right around the shape. So that is going to be x plus 3x. You move on to this x. You move on to this 3x. We are back to the starting point. So you're supposed to add everything. So that's the expression for the perimeter. You can even simplify this. And if you simplify, what are you going to get? If you add, this is just like 1. There's a 1 here. So you're going to add 1 plus 3, which is 4. Plus, this is also another 4 that we are having there. So that's going to be 8. So you can even add like 1 plus this, which is going to give us a 4. Then another 4, meaning to say you can even add and have 8x. Or you can just leave it like that. That is what you're given. Perimeter. Distance right around the shape. You add right around the given shape. So they can test you like that. 3.142. Calculate the value of x if the rectangle had an area of 243 square units. So they want you to, the moment they are saying calculate the value of x, definitely you are supposed to solve what? An equation there. It's an equation that you're now talking about. You're supposed to solve. So you see the part of equation. They're asking you equations in a hidden manner. They're just trying to hide that. So you're supposed to form an equation because they told you that the area is 243, the area of a rectangle. Given a rectangle, how do you calculate the area? Okay? Given a rectangle, we do understand that the area of a rectangle is given by length times the width. If you multiply the length and the width, you obtain the area. So guys, we are given that the length is what? Is 3x. So it means that if I multiply the 3x like this, if we multiply 3x times the width, what is our width? Our width is x. So if we multiply this to x, 3x times x like this, we must get the area. And what is our area? 243 square units. That is what they are asking you there. They are saying if the area is, we are assuming that the area is given. So we use what we understand about the area of that shape, which is a rectangle. Area of a rectangle is length times width. So this is length, this is width. Okay, guys, let's multiply 3x times x. This is 1 here. This is 1. So it's 3 times 1, which is going to give us what? 3. X times x, which is x squared. This is equal to 243. So like I said, guys, the moment that there is an equal sign like that, what is it that you're talking about? That's an equation. So you need to solve for x. So the question is, how can we find this x? Get rid of those 2, get rid of everything to find so that you remain with the x here. How can we find x? Okay, let's start with the 3. 3 is multiplying. From the multiplicative inverse, we can divide by that number that is multiplying. So we can divide simply this by 3 so that we get rid of the 3. We remain with x squared. So that's x squared is equal to 243 divided by 3. That is going to be 81. Okay, you can even use your calculator there, guys, to divide. We can just divide 3 into 24, that is 8. 3 into 3, that is 1. So that was going to give us 81. 243 over 3. X squared is equal to 81. How do you calculate x at this age? At this stage, how do you remove these 2 here? That is on the exponent, the power. The opposite of that power 2 that you see there is the square root. Whenever you have that is equal to 4, you put a square root to remove that power 2. It is opposed by a square root like this. The moment you put a square root, you are neutralizing these 2. So you are just remaining with what? With x, which is the square root of 4, which is 2. So if it is like on this person, it's still the same thing. There is a power 2. So we introduce the square root. Square root both sides, square root both sides. It neutralizes everything. So there we now have x. The purpose of putting this square root is to remove the power 2. So we are no longer having power 2, we're just remaining with x. Okay, so this is equal to the square root of 81. A number that you multiply to get 81, it multiplies itself 9 times 9. Just like 10 times 10. It must be a number multiplying itself to get that given number that you're seeing. So that number was going to be 9. So x at the end was going to be 9. If you solve this equation, remember they said, calculate the value of x. You're supposed to solve for x. Okay, so it was a statement that was a continuation, this question from the previous part. 3.152a plus 5a is equal to 8. What are we supposed to do? This is an equation. There's an equal sign. So that's an equation. An equation, you solve for the unknown, then later the variable that you're given. So you're supposed to solve for what? For a. But these are like terms. We can add 2 plus 5. That was going to be 7. So 7a is equal to 28. How do you remove the 7? Multiplication, multiplicative inverse, divide by 7 both sides. So a was going to be 28 divided by 7, which is a 4. 7 into 28, that will be 4 times. So a represents a 4. A is equal to 4. That's an equation. 3.16, this is b plus b. What are we supposed to do here? This is not an equation. We do not have an equal sign. So we're just supposed to add. This is 1. This is 1. These are like terms. That is, there's a 1 here. There's a 1 here. So you add 1 plus 1 plus 3. So 1 plus 1, that's 2 plus 3, which is 5. So this one was straightforward, guys. It was going to give us 5p. So I just given there 1 mark. 3.17, they are saying 3 times a number. Okay? 3 times a number. Remember I said whenever they say a number times a number, we do not know that. So it's x. So 3 times a number x, that is 3 times x. 3 times x is equal to what? 3x. Okay? That is what it means there. 3 times a number. But what happened? Subtracted from 78. Okay, guys. Yeah, there we have to be careful. I talked about that word from. From. Here. From what? From 78. Subtracted from, meaning to say, this here is the one that was removed from 78. So you start with the from. This statement, because of this, you have to start from. That, where are we coming from? Start from there, from. So it's supposed to be 78 minus, because we subtracted this from, we removed it from 78, this 3x. It was removed from 78. So it means 78 minus 3x, minus 3 times a number. Guys, be very, very careful. Your word problems, those small English terms, let us revise them. Subtracted from, it is removed from this. You start from there. We saw it from that previous question that we had, if you still remember. So they are saying, when it has happened this, that we have subtracted this from 78, is equal to, the moment that we are saying is equal to, that's an equation. We have formed an equation now. It is equal to what? To 15. Meaning to say, we have an equation, because we are saying this here is equal to this. So they were saying, write as an algebraic equation. Take note. And they're even writing in upper caps for you to understand that you're not ending there. You're supposed to also find the number. What is representing the number? Remember, the number is representing what? X. So they are simply saying, find X, solve for X, calculate the value of X. That is what they are saying, because the number is what? The number is X. So it's an equation that we have formed. Therefore, solve for X. Okay, so let's solve. How can we solve, guys? We can take the 78 that side. It will be a minus. It was a positive, so it's going to be minus 3x is equal to 15. We take the 78, jumps the moment that it jumps that equal sign, changes the sign. So it's now minus 78. That's minus 3x is equal to, guys, at this stage, you can just even use your calculator there. 15 minus 78 is what? So that is going to give us negative 63. Take note, this negative 3 is still there. It does not disappear, this one, because you took the 78, that the other side. This does not give us the power to remove this. It does not give us the power to remove that. No. There is still a negative there. Then we remove it, the negative 3, by dividing. So divide by negative 3. So that was going to give us a positive 21. 63 divided by 3, that's a positive 21, 2. And here, that's 1. So x was going to be equal to a positive 21 in that case. A positive. So Once you take this to the other side, it does not affect here. No, this one remains as it is, as a negative. Okay, so the way that you can solve, it's up to you guys. You can even choose at this stage how to solve. It's now up to you. How to solve there, it's up to you. You can even choose like here 78 minus 3x is equal to 15. If you wanted to avoid this to be negative, you will have to take it to this side, and you must take the 15 this side. So it will be like this: 78 minus 15 is equal to, you take the minus 3x that side, so that it will be a positive. If you wanted it to be like that, it will be positive that side, but 15 is now negative. So it's 78 minus 15, which is 63, is equal to 3x. Divide by 3 by 3, still gonna get a positive 21. So 21 is equal to x. It's the way that you solve. It's in your hands. Could you have solved it this way? It's in your hands. Let's revise as much as we can. Question number 4. Determine with reasons the variables or unknown values in the following figures. 4.1. X. So there, it's a right angle triangle. We do understand that there must be 90 degrees there. So how can we find x? We can simplify x by removing these two angles from 180 degrees, because we do understand that the angles inside a triangle, they add up to 180. So x is equal to 180 degrees minus, we subtract the 90 degrees, the right angle, it means 90 degrees. So you subtract the 90 degrees, you also subtract the 48 degrees. That is angles in a triangle. So that is angles in a triangle. Remember that the angles in a triangle, they add up to 180 degrees. So meaning to say the x in this case, if you subtract, properly subtract this, was going to give us 42 degrees. Angles in a triangle. You can even present it this way, like to form an equation, like x plus, you add this 90, you add 90 degrees, you add 40 degrees. I mean, the 48 degrees is equal to 108, like this. You can form it as an equation. Then you find x, so you still see that x will be equal to, remember, you can take these angles to that other side. So 90 to the other side, it would be a negative. 48 to the other side, it would be a negative. So still, you have got your x, which was going to be 42 degrees. Okay. Or you could have simply calculated this x in this way. Since you understand that this is a right angle triangle, that there is a 90 degrees here already. So what does it mean? It means these two remaining angles, they must give us 90 degrees, because out of the 180, remember guys, this is out of 180. 180 minus 90 is what? Because you have removed this 90. So 180 minus 90, we are going to remain with what? 90 degrees. 180 minus 90. You are going to remain with 90 degrees. So it means these two angles that are remaining, they are supposed to add up to 90 degrees. So you can simply find x by doing that. X is equal to what? 90 minus 48 degrees. Because we know that the remaining angles, they are supposed to give us what? 90 degrees. So we could have also determined it that way. Guys, there are so many ways. So many ways. Okay. 4.2. We need also to find this one, 8 marks. Okay, let's see. How can we determine A? Because we're given parallel lines. In that case, these two lines are parallel. So angle A can be calculated or can be stated. Remember, there we are forming a Z. Alternate angles where we form a Z. Just that this one is it's a Z which is stretched. It's a stretched Z. So A is equal to 110 degrees. Thus, we're going to talk of what? The alternate angles. So I'm just going to have this alternate angles. It depends with which part did you start with. If you started with the Z, it's another thing. So it's going to depend, guys, the way that you see. But your A is supposed to be 110 degrees at the end. Whatever that you use, you must have your A as 110 at the end. Okay? So please do whatever way that you can have. X from the co-interior angles, because of the parallel lines that we see, you're forming a C here. You're forming a C. So remember that co-interior angles, they add up to 180 degrees. If you add the angles A and B, you must get 180. So X can be calculated. Still, it's going to be 180 minus 90 degrees, which is what? 90 degrees. So that was going to be the value of X. Co-interior angles, where we form a C. From there, co-interior angles. So like I said, you can use anyway, guys, as long your X is going to be 90 degrees. That is what is important, because there are so many ways there. You can find the value of Y from angles on a straight line. You can find the value of Y by the corresponding angles. It is corresponding, from the co-interior angles again on this one. The co-interior angles with 110 degrees. Or you can find it from angles on a straight line. So whatever way that you're going to have there, Y is going to be 70 degrees, 180 minus 110, or it's 180 minus this 110. Y was going to be 70 degrees. So like I said, I do not know which part we're going to use. Are you going to use angles on a straight line? As long your Y is 70 degrees, it's fine. So there, I'm just going to use angles on a straight line. On a straight line. So I do not know which geometrical concept that you applied in order for you to have that. Again, we could have maybe you calculated Z in the first place because Z is angles on a straight line. Or maybe from this Y that we are seeing, we can see that these are alternate angles. We are creating a Z. So if this is 7, this is also 70 degrees. So the angle Z, 70 degrees. Is it angles on a straight line? Is it about the co-interior angles? Because it's also a co-interior angle to this 110 degrees. Remember, co-interior angles, they add up to 180 degrees. Guys, anything, is it from the sum of angles inside of a quadrilateral? At the end, our Z was going to be 70 degrees. So I do not know which part are you going to use. Is it from the alternate angles, like what I said here, that you're creating a Z angles on a straight line? Okay, so just do revise as much as you can. The properties of your parallel lines, I think I talked about that. So make sure each and every property is understood. On 4.3, we are given this is a parallelogram, ABCD. This is a parallelogram. We are given the property, already the name of the shape we know. So we can use the properties of the shape if it is like that. Remember the properties of a parallelogram: opposite sides, parallel and equal. Opposite sides, they are parallel and equal. The opposite angles of a parallelogram, they are equal. These angles, they are co-interior angles, they add up to 180 degrees. These two angles, they add up to 180. So we can determine this B. B is not an angle, B is the side. As you can see, there's a 5 centimeter. That's why they're giving us this B. So B is equal to 5 centimeters. So that is what, from the properties of a parallelogram, we do understand that opposite angles are equal. Opposite sides are also equal. Opposite sides are equal. They are not just equal, parallel and equal. We can determine this angle D here, D here. As long as you're in a parallelogram, opposite angles are equal also. Opposite angles are equal in a parallelogram. To find the angle that is at C, this one, you can use now the co-interior angles. As you can see that we are forming a C. So that's we've got the co-interior angles. This is 100. You can also use the co-interior angles from this side, whatever way that you want. So C was going to be from 180 degrees. We subtract the 100. Is it this one or is the other one? But that was going to be 80 degrees. So we are talking of these are co-interior angles. Co-interior angles, they add up to 180 degrees. Is it from this 100? Is it from the other 100? Where we form a C. So once we're dealing with the shape also, there are properties there that you're supposed to work with. Question 5. Your friend is struggling with the similarity and the congruence. So they are saying your friend is having a difficult with the similarity and the congruence. How would you go about explaining the difference between two concepts using diagrams in your answer? You want to explain the differences between these two, the congruent figures and the similar figures. So how can you best describe? It's up to you, this one. This one, it's in your hands, the way that you're going to explain. All right, let's start with the congruent figures. I have congruent, and on the other hand, we're going to have similar figures, okay? Then here, we're going to have the similar. So you can use anything. You can use shapes, triangles, rectangles. I'm just going to use triangles, which is best for us to understand this. If two figures are congruent, if two triangles are congruent, they are exactly the same. Exactly the same, of the same size. Identical. They are exactly the same. But if two triangles are similar, one can be smaller, another one can be bigger. It's not about the size of the shape that you are given. It's on the angles. So these ones, the congruent figures, they are exactly the same. Exactly the same. Meaning to say they are identical. They are identical. They are identical. But similar figures, one figure can be bigger. One triangle is bigger, or one object or one figure is bigger than the other. That is what you can see. So it will be how the angles are related. If the angles now are the same, these figures will be similar. And on similar figures, the ratio of size, this and that will be the same. But We just want to tell someone how to see the figures that these, like just to, you are given something that you can identify by sight, by just looking into the diagram. How can someone see? That's what they're asking you. So this is what we had, guys. Let's revise as much questions as we can to prepare ourselves for the tests or the exams, which are ahead of time. For others, we have already wrote. We just hope everything was fine in your tests, but we are going to work out earlier for our next trimester, so for our next term, so that at least we can have these tests before our exams. So this is what you had, guys. Till we meet again.